Alright guys, last lesson of the chapter. We are going to graph inequalities. Now, graphing inequalities is similar to graphing just lines without the inequality symbol. And actually that's how we begin. Now the first thing you have to do, and do this every time, is see what kind of line you're going to have. If you have a less than or greater than or equal to sign, if you have that line underneath it, that means you're going to have a solid line, like normal. But if, for instance, it does not have an equal sign, this will be a dashed line. Okay? That's one new change. The other change is that we're going to shade a certain way. So, because it's not just a line, we're going to be anything bigger or less than that line. So let's do our cover-up method for this one. When y is 0, I get... So when I cover that up, you don't have to do that on your paper. X is equal to 2, because 8 divided by 4 is 2. So I have this point right there. Now, if I cover up the other one, when I make x 0, that goes away, and I get y is 4. Now I draw a straight line. Well, or you can use this as a slope. 1, 2, 3, 4, 1, 2. 1, 2, 3, 4, 1, 2. To get more points, to make the line a little bit better. Alright, so again, I said solid. I'm going to graph a solid line. And that's what I'm doing right now. You're not done though, because with inequalities, you have to shade one way or the other, and you have to figure out which way is correct. The best thing to do is test a point. Pick a point either on this side of the line or this side of the line and see if it's true or false. For this chapter, we're shading true. And most of the thing you'll see, you'll shade true. Next chapter, when we do linear programming, with a bunch of different shading, we actually shade false to make it easier for us to see the answer. But on standardized tests and everything else, we shade true. So, for example, here's a test point. I'm going to try 0, 0, which is right here. You don't have to mark that, but I'm going to test that point and see if this is an answer to this equation. So, is 0 plus 0, because I put a 0 in for x, a 0 in for y, greater than or equal to 8? Hopefully you say no. That means that this point is not a solution. So that means that I am going to shade instead the other way. So the answer is this line and everything to this side of it. Okay, so this would be my answer for the problem. And that is graphing that inequality. Alright, let's do one more. Well, we have actually a couple more. So now, this one, again, you can use the cover-up method. You can use the cover-up method to solve this. I have 3x equals 3, which means x equals 1. And when I cover up the other one, because we're in standard form, don't worry about the inequality symbol. Just solve this. Divide by negative. Y equals negative 3. So I have up 3 over 1, up 3 over 1. The reason why I'm putting the the reason why I'm putting the dots on is because what kind of line do I have to make here? I have to make a dashed line because it is not equal to. So that means that the line itself is not a part of the answer. This is a key. You will lose a point every time you do this wrong. So don't do this wrong every time. So now that is my new equation. The best thing always to do is test the point 0, 0 if possible. You cannot test 0, 0 if it's on the line though. So we're going to test 0, 0 because it's on this side of the line. I get 0 minus 0 is less than 3. I just put a 0 in here and a 0 in here. And what happens is that is a true statement. So that means that this 0 right here is on the correct side of the line. So that means I'm shading up to this dashed line and everything on this side. And we're done. Okay. So again, it's like graphing the lines before. 2 new steps. 1, you have to decide if it's dashed or solid. And 2, you have to figure out which side of the line you shade. Alright, good. Now, let's come up. This is a very important lesson, or this problem is very important because this will lead into what I was talking about before with linear programming. You have to come up with an equation or given an equation, and you get a bunch of things you have to graph then. So you have $200 to spend on CDs and music videos. CDs cost $10 each, music videos cost $15. Write a linear inequality in two variables to represent the number of CDs X and music videos Y you can buy. So what we're doing here is we're coming up with a standard form inequality. And it didn't say I have to spend all of my $200, so that's why it's an inequality. $10 for CDs plus $15 for music videos. It can be equal to 200 and it can be less than. We obviously cannot go over 200. So this side of my equation can be like $150. I could spend $150. I could spend $120. But I cannot go over 200. That's why it's less than or equal to 200. This side has to be less than that or equal to it. So I just came up with my equation. We can now use this this inequality to solve. So I'm going to find out what I can do with this by using the cover-up method again. So when I cover this up, I get 10x equals 20, or sorry, 10x equals 200, which means x equals 20. So since I only have this by 5s, actually I'll do this by 2s. Let's do this by 2s. I'm going to say this is going by 2s, so that means this is 2, 4, 6, 8, 10, and this is 20 right here. Then if I cover up the other one, you get 200, and you get about 13.333 repeating. Well, actually, it's exactly 13.33 repeating. So 13 would be 2, 4, 6, 8, 10, 12, 14, so it's about there. That's about 13.333 repeating. So the one intercept is 0, 13.3 repeating, and the other one is 20, 0. I'm going to graph this line. Do I want to go anything higher or lower than these points? No. I'm not going to graph over here. Can I have negative music videos or negative CDs? I'm not like trading in CDs here. So I also look at my inequality and notice that I have a solid line because of this. It's going to give me a solid line. So my graph will look something like this. And now just think logically here. I have to shade one way. I have to either spend $200 or less than $200. If you think about that logically, that means that I probably can spend anywhere in here. Well, that's going to be hard to do. Yeah, I can't get in there. Alright, so it's everything under the line. Anything under the line. I'll do that. Alright, so anyway, anything under the line works. If you have 0, 0 or higher, you can solve this. It would be part of the answer solution set for this inequality. So it says list 3 possible solutions for real life situation. Well, you can make anything up that's in here. I could do 2, 2. 2, 2 works. I can do 20 CDs and 0 music videos. I can do 8, 4 if I wanted to. That's in the solution set. I could pick really any point underneath that. That's what they're asking for. Okay, so again, we didn't graph any of the negative stuff here because we're dealing with real life. No negatives. All right, last problem. You have $15 for fresh fruit for party. For a party. Write a linear inequality in two variables for how many pounds of strawberries X at $1.25 per pound and cherries Y at $2.40 per pound you can buy. What are intercepts of the graph and what do they represent? So let's write our problem first. We know it's $1.25 per pound of strawberries and $2.40 per pound of cherries. we only have $15, so we have to go under that or equal to $15. So that is my standard graph again. Now I'm going to find both intercepts by using the cover-up method again, or plugging zeros in. So if I plug a 0 in for this, I get 1.25x is equal to 15, x is equal to 12 when you divide that. So one of my points is 12 comma 0. The other thing I can do is cover up the 1.25x and say 2.40 is equal to 15. 2.40y is equal to 15. And then solve for that, and you get y is approximately 6.25. Or actually, it's equal to that. So, 0, 6.25. What do these things represent? What are the intercepts? I just found them. What do they represent? Well, they represent that I'm buying all cherries here. And this means I'm buying all strawberries. Okay? And if you wanted to just graph it again, we would only look at the first quadrant because it's positive, and this would be pounds of cherries, not number of cherries, and this would be pounds of strawberries, and we would say this is about 6.25, and we'd say this is 12 comma 0, and it's equal to, so the line is solid, and again it would be shaded underneath because we do not want anything over $15, and that would be what it looks like if I shaded it. Okay, so the cricket problem I'm not going to do on this note sheet for the video. You guys can try it on your own tonight for an extra homework problem. I'm going to go over it in class tomorrow. We can work on it together. It's kind of like the ones from the word problems. It's another one where you have to come up with your two variables, come up with your points, find the slope, find your equation, answer questions. Okay? So this concludes chapter 2. And like I said, we'll go over anything you need to tomorrow in class. Or I guess if it's the weekend, then Monday in class.